Now let's look at MMP. I want to show you our prototype implementation of MMP and how it works. After that, we'll repeat the experiment that we just saw, except that this time we'll be using MMP instead of mobile IP. This is a screen of the MMP gateway. The topology is the same as what we had in the mobile IP prototype, except that some of the nodes now serve different functions. What used to be the Linux router with mobile IP is now the MMP gateway. It's here. What was the mobile IP home agent is now MMP base station 1. And then over on this other side, the mobile IP foreign agent is now the MMP base station 2. And we can see that the mobile host is being served by MMP base station 1. How are packets getting from the correspondent host to the mobile host? From the correspondent host, they take this route indicated in red through the MMP gateway down to MMP base station 1 and then out over the wireless link to the mobile host. The difference between this and mobile IP, as you may recall, is that within this MMP domain, routing is done using routing caches rather than standard IP routing. Now let's look at the mobile host moving from base station 1 to base station 2. This is the mobile host. I'm going to initiate a handoff now from base station 1 to base station 2. The handoff to base station 2 is now complete. Let's take a look at the route taken by packets from the correspondent host. They go along this red line and they come to the MMP gateway and go directly to MMP base station 2. From there, they go over the wireless link to the mobile host. What has happened is that at the MMP gateway, the routing cache has been updated so that packets for the mobile host no longer go to MMP base station 1, but they take this other path on this leaf 2 to get to MMP base station 2. You may recall that with mobile IP, what would happen is that packets would go to the home agent first and then would take an inefficient triangular route to the foreign agent before getting to the mobile host. As you can see, MMP provides very fast, low latency handoffs. It also provides optimal routing within the MMP domain. We are now going to repeat the experiment which we had done earlier with mobile IP, using MMP this time so that we can look at the performance of MMP. We are back at the correspondent host and we're repeating the experiment which we had done earlier with mobile IP, except this time we're running MMP. Recall that the experiment involves sending packets from the correspondent host to the mobile host and getting responses back from the mobile host. When communications are smooth and with little interruption, we expect that the replies would come in at a roughly constant rate. However, with mobile IP previously, we had seen significant interruptions, noticeable interruptions causing delays in the response times. What we're doing now is that we're running MMP with handoffs occurring every 5 seconds, and yet there is no noticeable interruption. This shows that MMP does indeed provide fast, low latency handoffs. You have just seen a demonstration of our prototype implementation of MMP in our laboratory testbed, as well as a demonstration of our prototype implementation of mobile IP in the same testbed. In addition, you have seen a demonstration of an experiment that shows the disruption caused in communications between this mobile host and that correspondent host when the mobile host is moving and handing off back and forth between two base stations in the same domain. Unlike mobile IP, MMP performs admirably in this situation when the handoffs are occurring. There are no noticeable disruptions in communications. I hope you have appreciated this demonstration, and thank you very much for watching.